All right, so good morning, everybody, and welcome to the developer user group and Salesforce Apex Hours. Today we have with us Mohit Srivastav, and he's going to show us how to use Salesforce DX for non-scratch orgs. Uh, Let me speak a little bit about myself. I'm Prajakta Saman, leading partner user group here in India, and also working with Eternus Solutions as solution architect. And that's all from my end. Over to you, Mohit.
All right, thanks, Prajakta. So hey everyone, again, welcome to another session of Apex Hours. So our topic for this session is Salesforce DX for non-scratch orgs. So we're gonna talk a bit about what is scratch orgs, how do non-scratch orgs differ from them, using Salesforce DX, basically for non-scratch orgs, like what are the source code, directory structure differences, what are the basically, some of the new commands that got added in Winter 19, like retrieve, deploy, and delete, which are still in beta, but very effective. So we're gonna take a look at how we can use these commands, to automate our developer workflow. And then we're gonna play around with the Salesforce extension for VSCode and see what it has added in the Winter 19 and how we can leverage it, especially against non-scratch orgs. We all know the capabilities with the scratch org. So in this session, we are particularly be concentrating on non-scratch orgs. Also, I'm going to show you some shell scripting, how we can use shell scripts to, automate few more things that, the CLI doesn't actually automatically provide today, like generating package XML from your changesets or unmanaged package code or managed package code. And then, basically how to use the, debugging capabilities that, that's baked into the Salesforce extension for VS Code. And also we'll take a simple demonstration of how we can actually use this to deploy metadata from one org to the another using either, the unmanaged package source code or using the chainset approach. Let's get started here. So first we'll get started on what is scratch org based development model, right? So this is the new model that was introduced last year, and it's pretty much the recommended actually model if you are development strategy, if you are actually starting new projects, or if you have a small project which can easily be converted into DX format. So basically it comprises of, we have a CLI, Salesforce CLI for DX. So the CLI provides you the capability to take the source code from the Git repository and convert that source code into a workable org where it has all the code and the config that you have done and hosted on your source control system. So it's basically spinning up a new disposable orgs. When I say disposable, that means, you can create it, you can delete it, you don't have to, you have to script all the other things there in the scratch org model. That is, if you want to insert data and if you want to do some config on top of, whatever the source code that you have. So you can script all those things, and then what you do is basically you take that source code, generate org, work there. And the CLI provides you with the command sets like force source push and force source pull. So basically anything that you do in the scratch org, like a config or a code change, is tracked. And next time when you do a force source pull from your CLI, you actually pull the differences between your local machine and the Salesforce. So the scratch orgs are automatically, tracking, with the combination of DX, they are tracking what are the changes that you are doing in the org. And with one simple command, it's pushing only that delta change that you did in your local to the org, and it's pulling back the same thing if you have done in the org back to your local machine. So these two commands keep it in sync. And then what it provides you is it provides you the packaging capability. That is, you can generate unlocked packages, you can generate first generation managed packages and other packages here, and kind of install that package in another instance. So for example, if you see the flow, right, a developer actually, if you have multiple developers working on your team, every developer can take their own branch from the Git and create scratch arcs and work in that scratch arcs and compile or check in against a continuous integration uh, built-in source control system. Like, let's say they all push towards an integration branch, which further gets built up and validates it. And then the release manager actually takes one of the branches and generates a package out of it. The package is actually installed in the staging environment, UAT, and then you deploy to other higher environments as a package. Now, this is for the package development, right? Very suitable if you're working in an ISV or you're building an application, app exchange application. Then this model actually makes a lot more sense, and this is the way to go. If you're working for system integrators, right? In that case, this model still can apply, but you will have to use something called as unlocked packages, basically. So unlocked packages are, basically you take a particular functionality and or a business set of business requirements that compile into a module. So you build that, and then you actually deploy it into your environment, and you manage the whole release around that. That is, if you need to enhance the functionality, you generate the second version and then deploy it, and you can manage the whole release cycle around it and the governance around it without without too much of, let's say, involvement of your administrators. So that is the difference between unlocked packages and the unmanaged packages. The unmanaged packages does not allow you to upgrade, while the new unlocked packages allows you to upgrade. So that means unlocked packages are also suitable for system integrators. So this is the scratch arc based development model. Now, we know that this model will take some time for everyone to adopt. There is going to be a lot of learning curve here to understand various nitty-gritty that is there in the scratch arc model. And also it will require really programmatic developers, right, to create integration scripts and all the self scripts and things like that. So what about developers or organizations basically who have less number of developers and who have a large organizations with lots of metadata, which will take some time for them to actually segregate it and build unlocked packages out of it. Still, there is going to be a lot of effort. So we are all used to, prior to DX, we are all used to this type of development, which we call it as chainset based development. So in the chainset based development, what we do is we assign an arc, right? Every developer can have their own sandboxes, which we have the ability to actually refresh it from the production. If it is a developer sandbox, you can refresh it every day. If it is partial or full copy, there are certain limits to it, right? But that's the development model we used to be, where we used to actually do our development in one of these sandboxes and kind of use chainsets to actually push that declarative change to the higher environments where it can be tested. And then we have a test release chainset, which further moves into other environments after testing, right? So this model is highly suitable if we had lots of declarative developers, not so much automated, right? It requires some amount of understanding, to understand the metadata of Salesforce and the XML behind it and all this thing. And if we had only declarative developers and small organization but with a big org, right, this model actually worked for us. So in this session, actually, we are not going to focus on scratch arc based development model. There are already sessions and Dreamforce sessions that you can watch on YouTube, and I highly recommend that you actually start thinking through the scratch arc based development model, which is basically provides you a complete source driven development experience. However, the chainset based model is still common, and you can still use it. It's a well defined model. All that you need is a well governance around it and the release management around it. So in this session, what we're going to do is how to use the Salesforce CLI and the VS Code extensions that Salesforce has, um, to do development in a chain set based development model, right? So we're going to see how it sort of acts like an intermediate solution today with whatever the enhancement that Salesforce has done in the new release, and we're going to take a look at how we can leverage it and still use it with non-scratch arcs. So non-scratch arcs, when I say non-scratch arcs, what that does mean is your developer arcs, your sandboxes, anything that is not scratch arc. So these arcs can be persisted, right? They persist and they don't actually expire unless you don't do any activity there, right? So these arcs don't expire often, and you can do pretty heavy customizations there, and you can persist that, so which is a good thing actually. Some of the projects which might involve a lot of heavy customizations, right? So it's important to persist them, right? Not just in the source control, but as an arg you want to persist it, right? So this type of model can be really helpful there. So before even we actually jump into, so in this session, what I'm gonna try and do is show you how to use these extensions and how to use this for chainset driven, chainset development model, that we talked about the slide, the chainset based development model. But before that, let's take a look at some of the highlights of what is Salesforce DX source code format from the traditional metadata API format. Like, how does it differ, right? We're gonna also look at it when I'll actually show you a demo and actually work in one of the arcs with one of the apps. But for time being, the major differences that you will see, in the source code format than traditional is everything here is actually segregated, meaning it's not one XML packet anymore. It's a syntax, sugar syntax on top of on top of whatever we had. Like, for example, if you look at the metadata API format, right, which we're going to take a look at just now. So you will see in that format, object metadata will be a bunch of XML, which doesn't segregate fields, which doesn't segregate compact layouts, all these field sets, list view, record types, and all. With the new, source code format, you can actually, everything is divided into its own subdirectory, which makes it easier to actually browse through and things like that. And the development for chain set based model can also leverage this kind of a source code format. Like, you don't have to work with your traditional source code format. It can be in the DX format, and that's what I'm going to show. You can actually use that format today, convert your existing projects where you used to actually use Eclipse or Maven's Mate to actually use this new Winter 19 features, and convert your existing project into a DX type of a format, but still work with your non-scratch arcs. You don't need to actually think about creating dev hub and scratch arc model and et cetera, for the short time with all these new functionalities that's been added. So other important differences, from the traditional code format is the static resources are uncompressed in DX, meaning, you can edit them in your ID. Earlier, it used to be .resource file, and you cannot edit them. It's a compressed file. It's locked for editing. But now it makes it super easy to develop your, JavaScript based applications, right? Because you can edit everything from the, from your editor. And once you actually push the source code, the Salesforce CLI automatically takes care of compressing it for you. And when you actually pull it, it takes care of uncompressing it back to you so that you can work with it. Some of the things are lightning bundles are organized. Documents are organized into its own folder directory. So it's a lot better, source code format, basically. That's what I want to say. And this is the source code format that we should be working at, because this makes it easier for us to actually find, like how many fields have been created on this object. What are the list views that are there? What are the record types? Are there any sharing reasons? Are there any validation rules, etc., etc.? Right? It makes it very easy to actually browse through the directory structure here. So let's summarize this before we actually dive into a demo of how we can use all these things and other things that I have. So it's very important to understand these two models that we have today. The scratch arc development based approach, which is basically the source driven development that I talked about. It will require you to convert your existing projects to DX format, um, you know add capability to create scratch arcs, manage scratch arcs. It's a disposable model, very much preferred if you have heavy programmatic skills with you, and you are ready to invest in some scripting. Suitable for applications like if you're an ISV, this point applies to you. This is suitable if your application has less number of post install configurations. Now these things might change in the future with org shapes and templates, safe harbor. But for the time being, that's one of the drawback. If you have more number of config steps, and if you're working on top of other applications, like if you have an application which sits on top of health cloud or financial cloud or CPQ, et cetera, which involves a lot of customizations, right? Like you have these packages, you customize it, and then on top of it, you're building something via extension package or further customizing. So for these type of developments, right, we cannot use scratch or development based model, because you have to install it, you have to configure it, and you don't want to do it every time. And if you try to script through it, you will see that you have to invest in some scripting developers, right, who can script all those things for you. So for those type of things, chainset based model is still preferred. Like you can have in one org where you install the package, configure everything, and then other sandboxes can be spun from that, right, which provides an environment for every developers where they can do it, do this chainset based development. So again, highly recommended for ISVs will be scratch org based development model. But if you're an SI and still not moved to Salesforce DX, then using the CLI and the VS Code extensions and all the other Winter 19 enhancement, we can still actually work through that and have a middle layer which can help you slowly transition your app to one of the scratch org based development models. So this could be your first step, in adopting the CLI as well, and seeing how the Salesforce code base actually changes to a DX format. So before I actually just speak theoretically about all these new features, why don't we actually go to the demo and see how I create a project, how I deploy things, and so the core of all those things will be these commands that Salesforce provides in the beta release, in the Winter 19, which is, and they provide you ability to actually retrieve the source code from a non-scratch org using force retrieve, where it has different flavors. One of them is providing obviously the package XML. The other flavor is you can actually provide a comma separated list of metadata that you want to retrieve. Similarly, they have deploy commands where you can deploy specific file or deploy all the source code based on the package.xml command. And there are delete commands as well, if you want to delete something from the org. So one thing to note is this feature is in beta, meaning there won't be much support if you run into any issues that so you're on your own before this becomes GA. But so far it looks promising and in the right direction. So we're going to talk about that. So really to get started, the first step that you need to do is, if you want to use VS Code along with the CLI, is install all these things, all this goodness. So install Salesforce DX CLI. All these are available in Google. If you type install Salesforce DX CLI, it's going to give you the link to install VS Code editor, the text editor. So this is one of the the best editors that we have in our current systems of editor ecosystem of editors. So and Salesforce provides extensions, which is improvising with every release. It provides a lot of great capabilities already, like ability to execute anonymous apex that we're going to see, ability to do all these SFDX commands for both scratch arcs and non-scratch arcs. And also ability to debug using, we call it as Apex debugger or Apex replay debugger, offline debugging. It provides the ability to pull your logs from your Salesforce and debug it. Okay, so so let's actually jump into the demo um, before we actually see anything. So just a confirmation here. Can you guys see my Visual Studio Code?
Yeah.
Okay, thank you. Okay, thanks. All right, so the first thing is obviously installing the CLI. So I'm going to work few things in the command line today and also use Visual Studio Code, and the extension that Salesforce provides. So this is a Visual Studio Code, the interface. As you can see, it has menus here at the top, just like any editor. It's lightweight. That's the best part of it. It's lightweight. And all your extensions can be managed via a simple, menu here, where you can actually browse for the extensions and just click on it to install. Like, for example, we have a few extensions here already recommending for me to install. But as you can see, I have installed the extension for Salesforce CLI. So I have Salesforce CLI integration, and I think the extension is called Salesforce. It's called Salesforce Extensions for VSCode actually. So it installs a bunch of more things, like it installs its own Apex editor, interactive debugger, replay debugger, the tool set for the Lightning component framework. This is the one that I was talking about, the Salesforce extensions for Visual Studio Code, right? Also provides you instructions on how to work with it. It's not deep learning curve. Once you actually go through it, create few projects, you know how to work with it. Also provides you editing capability for Visualforce. And you can install some more recommended tools, like I've installed Apex PMD, which allows you to do a static analysis of your Apex code. And also you can install a few things like XML tools, because some of the metadata in Salesforce is all XML based. So this allows you to actually query for the XPath or C and analyze it further. So there are other extensions, useful extensions that are recommended. So you can install all those goodness here. So now I've installed everything, and let's take a look at what else. So also the CLI, right? So the CLI installation is very simple. If you have a CLI, you can run this SFDX help. Now this is going to give you the set of help commands. So just to make sure that I have the CLI installed, I just type this. I can see, yeah, I have force and help commands available to me. And there's also ability to create CLI plugins and things like that. If you're interested, you can watch few sessions on this, and which was done in Dreamforce on the on YouTube. But for time being, our discussion will be limited to how to work with non-scratch arcs and things. So first thing, let's see. So first thing is, once you have installed, I assume that this extension is installed and the CLI under the hood is installed. So let's simply go create a project here. So how do we create a project currently today? So if you go to command palette, so command palette is where you'll find all the all the code. So now what you're gonna do here is you're gonna say SFDX, right? You're gonna say create a project with manifest. So let's see what it does actually. So don't pick up this SFDX create project, because this one, what it will do is it's for the scratch arc based development, right? Where you have a you have scratch arc configuration file with you, and you want to create scratch arcs based on the definition that you have defined in that configuration file. So in this example, what we're going to do is we're going to use this command, which basically is designed to work with the non-scratch arc. Let's create a project with the, so the first thing it's going to ask is the project name, right? So we're going to say Apex Hours project. You can name it anything based on your project. Say enter. It's going to say, yeah, where do you want to keep this project, right? Which folder. So currently I have a folder, so I can say, yeah, create the project there. It's going to create the project. So it's running, as you can see, it's running a command here. So what this is doing is it's creating the, it's scaffolding. Basically, we call this as scaffolding. So it scaffolds an application for us with default things. Like, for example, as you can see, it's scaffolded manifest, which is a bunch of package XML basically. So this package XML by default, what Salesforce says is if you authenticate this project with, with other, with a non-scratch environment, by default, we are going to pull all these things into your Force app directory, which is your, our directory here, and we'll have Force app directory where we'll have classes, triggers, etc., right? So by default, we say this. Now, your org might have a lot of more components that you want to pull, right? So you need that proper package XML, right? You need the proper package XML to actually pull in those things for you. So now, here in this scenario, I'm going to show you also that how you can auto-generate that package XML from your chainset or from your unmanaged package. Now, when I talk about unmanaged package, it need not be actually compiled and uploaded. An unmanaged package in Salesforce is just a container. So if you add a component to an unmanaged package, what it does is it also adds a related component. So we're going to talk about how we can create those unmanaged packages, and you need not necessarily actually upload it. Instead, use it to generate a package XML automatically for you through the CLI. Now, you can use other tools as well to generate this package XML, or your old IDE like Eclipse might have this package XML for you. So you can simply replace this file with that particular package XML file. That will also do. But ideally, we want to keep generating that package XML from the CLI, as we build through. So I'm going to show you how to do that. So let's do this. So now what I'm going to do here is, so where is this project connected, right? You need to establish that connection to which Salesforce org, right? So to do that, again, you go to the command palette, you go there and say, yeah, I want to authenticate or authorize an org. So you see there is a command called as authorize an org. So click on that, authorize an org. So it's going to ask for an alias. So an alias is every org that the CLI actually authenticates to. You assign an org alias for that. It's a short form. You don't have to remember the whole username. Now for the scratch orgs also, we assign the alias. But remember, this demo is specifically for the non-scratch org. So I'm going to connect to one of my non-scratch org. Let me call it as dev org. What? You can name it something. Maybe with your name or anything like that. But it just requires an alias. So let me call it as dev org 1 here, right? I'm going to say enter. Now, as you can see, it runs this command under the hood called web login. And it automatically sets this as the default org for anything now, if you want to do anything. So I don't think you guys can see my other screen, right? So let me pull my other screen because I'm using dual monitor here. So now I believe you can see you can see this thing. So okay, so now I'm gonna connect to one of my orgs here. So I'm gonna say, yeah, connect to this. I have already the logged in credentials with me. It just logs in. Okay, so why is this error? An unexpected error has occurred. So let's see why this error actually occurred here. Let's see. So one of the things is, so if you are actually authenticating to a dev org, right, it has to be login.salesforce.com always. If you're authenticating to a Sandbox, you come here in the SFDX project JSON and you basically change it, right? That's the thing. So let me actually see why this, we should not be getting this exception basically. So maybe because I have a custom domain, I'm gonna just log into this. Maybe I have some policies. Okay, let me try logging into other instances here and see why this is not authorizing. Command palette, let's authorize it. Let's call it as, still call it as devorg1. Okay, let's log in here. It's running the command. I'm gonna try once more authorizing it. All right, it seems like it worked this time. Okay, so it got authorized. So it says you may close the browser, it authorized an org. So as you can see, the authorization was successful. Everything is fine. Happy path, right? It works. So let me pull that org in my. Can you guys confirm that you guys can still see my screen where I have the Salesforce instance open?
Yes.
Okay, perfect. Thank you. So yeah, so as you can see, now I've logged in into this org. So anything that I do will be associated. So this project actually basically linked to that, right? So as I said, my next step is basically to extract whatever is there, right? Like what are the components that I'll be working out locally, right? Because you want to have your Apex classes, your objects that you're working with here in your IDE. So as I said, one of the ways to do that is by using unmanaged packages. Again, you need not compile unmanaged packages, right? When think about unmanaged package, we always think about we'll take that, we'll upload that unmanaged packages. Like for example, let me go to my packages here. If I go to my packages here, as you can see, I have some packages. I've already pre-created this package Apex hours, where I've added some bunch of, custom object, one of the Apex classes. You can keep adding to this package as you actually build, Now I'm not uploading it. If I want, I can easily delete the package, and that's about it. You need not upload it. So this is just a container, And the good thing about this is, for example, if you add one object, it pulls all the related metadata along with it. That's a major difference between an unmanaged package and chainset. In chainset, what happens is if you add a component, it doesn't get you all the dependencies. Like for example, if you write an Apex class that has a dependency on, let's say, a custom field and a custom object, so and then the custom object has its own page layouts and things like that, right? So if you do that, right, what happens is unmanaged packages, if you add let's say a Apex class to an unmanaged package, it pulls all the dependencies. Like it will automatically add all the referenced objects, all the reference fields. If the object is added, it will obviously add its page layouts, its compact layouts, other things, and you can explicitly add it as well. So it manages the dependency for you. But in Chainset, it doesn't manage the dependencies for you automatically, which is also good, right? Because you might want to deploy only one specific Apex class, right? Or one specific set of changes to your release org, right? So Chainset, so remember the difference between chainsets and unmanaged packages are unmanaged packages automatically handle dependencies, which is very good for package development. Specifically, if you're doing managed package application development, you should use unmanaged packages to begin with to extract your your metadata to your local and keep that in the source control. And then finally, when you go to the packaging org, you can package that whole application, and the package automatically tracks all the dependencies for you. So you don't have to worry about, I missed this particular thing or this component or anything like that, right? As long as it's in the unmanaged package, it will be in your source control, as it will be in your managed package application. So this thing that I'm demoing is for an ISV development. For SI development, as I said, changesets doesn't track dependencies, but you don't need that because you're manually tracking it, right? So the next thing that I want to talk about is how to actually generate package XML, right? So by default, it generates this package XML, but we don't want only the defaults. We don't want only all Apex classes and Apex pages and triggers and our Lightning components and static resources. We want more than that. We want this package content to be pulled into our into our local, right? So let's see, how do we do that? So you go to, so this is a simple little gist that I kind of wrote. I call this out. So shell scripting basically allows you to take what shell scripting does is it allows you to take some of the commands that Salesforce DX provides and bundle them together so that you don't have to run each of these every time, right? For example, to generate a package.xml, I've written a simple shell script. So let's see, how do we use the shell script? Now, if you're actually working on, so I'm working on Mac currently and it works well with the Mac, the shell script. But if you're working on Windows, there's a way you can get the, the Linux installed on your Windows machine and use that. Basically, it allows you to give you a terminal and you can run all these things on the Windows machine as well. Unfortunately, I don't have one Windows machine, so I couldn't test it. But let's see. So let's create a directory here called scripts. Okay, so I created a directory called script, and let me create a file, and I want to name this file just like as it is here, package.sh. So where is it? Let's generate this file. I'm going to call it as package XML.sh. So sh is for shell script basically. So I'm going to take this whole shell script, copy it, basically paste it here. So this I'm going to share the link with you. It's on my gist actually. So if you go to my repo, you can find that gist actually. And this is very, very helpful. There's a lot of other enhancements that I've done. So I'll be pushing the next version. But this script, basically what it does is, what we do is the CLI has a command to actually retrieve metadata API package in the form of metadata API by providing the package name. So that's the API that it provides. So we can use that. We can unpack it, meaning we can unzip it, and we can unzip it in a specific directory called manifest. Now you'll see that when I run that, there's already a manifest created, right? So this package XML will be overwritten. So this script is basically copying. It's a simple shell script, right? It's copying whatever is there in this MD API package directory into the manifest directory. And then what it's doing is it's removing all other directories and all other metadata that we don't need here, right? So let's actually go and see how to run this. Now to run this, you need to first provide the permissions. First you need to so this can only be run currently, not from your VS Code, from your terminal instead. And there's an integrated terminal actually built into the VS Code where you can actually execute your commands. But you can also use your command prompt or terminal also, because that provides a better UI. I usually prefer to do there, not in the small UI. You can actually unpop it as well. So first I'm going to do this PWD. So it's going to tell me what is this path of my project so that I can CD into that. So I'm going to CD into that. So now I'm in this directory, right? So now the next step is to run this. So before we run this, we have to provide permission. By default in Mac OS or in Linux also, you cannot run a shell script just like that. You have to provide access or permission. So to the running user, we have this small little command which actually provides you the permission. I'm going to say, yep, provide me the permission for scripts folder in this file. The file is in the script folder, so it requires the path, right? The scripts, there you go, execute it, there you go, it provides you the permission. That's it. If it doesn't error out, that means it provides you the permission. The next step is actually to run this, right? So running a shell script is pretty simple. So all that you need to do while running a shell script is basically indicate the path of the shell script and provide the org aliases. So my shell script actually works with two aliases. One is the org aliases. So remember this. So this one is what I gave, right, when I actually aliased my org, right? So this is the alias, and you can also see this in the VS Code. It shows you, right? I said dev org1. That's the alias that this project is connected to, right? So now I'm gonna say, yeah, this is my first alias. The second alias is the package name, actually, that I want to pull the package XML from. So in this case, my package name is Apex Hours, right? So I'm gonna just substitute with that. So now I'm gonna run the script actually. So again, this cannot be run from the VS Code, it has to be run from the command line. Eventually, we might want to build a plugin or something that allows us to execute this from the command line without having to go through this, and then use that and link it to the SFDX so that we can execute as a command directly, and then write VS Code extension on top of it, right? Add it to this so that this can be executed from here. Anyways, that's a long road map, right, for us to develop. But if you execute this currently, what happens is this is gonna start creating that package XML for us automatically from the So it's retrieving the source, as I said. It's executing this second little command. Where is it? It's executing this retrieve command, then it's going to unpack it. It's going to remove some directories, create few directories, and then it's going to find the package XML, put it back into this manifest XML, and then remove that. We're going to execute all those things. So now you see it actually executed all these things. So let's see. So now we have this beautiful package XML that we need our CLI to work against. As you can see, it pulled in the custom object that we want, list views that we want, layouts that we had, custom fields, the Apex class that we had, just what we have in the package, right? Now, as I said, you don't need to actually keep this package. You can delete it. I would say keep it, but you necessarily need not actually upload it. Upload it to other higher instance or upload this, because unmanaged packages, once you upload, right, the disadvantages for unmanaged packages, if you move this to another higher instance and if you want to again move this as an unmanaged package, it doesn't, because what happens is, it's you cannot upgrade an unmanaged package, right? You can create versions of it which upgrades, but you cannot actually. The biggest disadvantage of the unmanaged package is basically it's not upgradable, right? If you generate like 1.2 version of it, you'll have to uninstall the previous one and then install, right? It's not upgradable like managed packages. So really, you don't need to upload or anything. Just create these packages so you can add your, this is like a package XML selector screen that we used to see it in the Eclipse IDE or the Maven Smith. Right, we used to have the screen where you say, I want to pick these components, and then I want to generate the package XML, right? The tool used to do it behind the scene. So currently, the Salesforce CLI actually provides you that capability, but it's all under the hood. But we can use the platform unmanaged, and so this script actually that I have, interestingly, it also works with the chainsets, and I have tested it. So when you actually authenticate to your Sandbox environment and provide the chainset name instead of the unmanaged package name, it actually pulls you and creates a package XML. Package XML, just like it did it for unmanaged packages. So now the next step is basically pretty simple, right? You go to the package XML and say, yeah, I want to retrieve the source from the org. So this commands are the new commands that has been added, right? So now I have the package XML. I can say, yeah, retrieve source from org, right? So I wanted to show this actually, but really you can, so this command that we have, package XML generator command, this can be enhanced to actually pull everything on the first attempt itself instead of running this. But anyways, that's also baked in. I'll share the code for that. But yeah, this demo, I want to actually click on it and say retrieve it. Now it retrieves. So as you can see now, yes, we have all these layouts. We have all these whatever the layouts that are there here, right? We have the objects. So we have the objects, we have the layouts, we have all these classes that we added in the package XML. So you have a working directory project, right? The only difference, as I said, is it's going to be in the DX source format, not in the metadata API format. And the differences, again, I talked about in the slide, the differences between that and this is, if you look at the object, so currently if I look at boat A__C, if I look at this, right, I can see there's a subdirectory for it where I can see all the fields that are there for this, all the list views that are there. And I can, if it had page layout, I think layouts are different. But if we had, so all these things that we talked about, right, in one of the slides, as that slide. So this one, right? If you have a business process, if you have a compact layout, if you have a field set, list views, record types, right? Validation rule, web link. So everything is segregated into its own directory. So it makes it very easy for us to actually say, look at it. Yeah, look at it and say, yeah, this is the field. Yes. And then I have this XML document opener where you can actually dig into, more things, right? You can actually browse through it. Like if I want to see what was the label, I just say label and it automatically does few things for me, automatically scrolls through and shows me that node for me. So this is the DX source format. Now, from this point onwards, right, it is very easy actually. If you want to actually say, I want to modify one of the classes, right, do something, it's very easy. So let's say I want to add something here. Public static. Let's say I want to code this. So Apex, right? So Apex. So I can say account, say get account. So I'm just writing a method actually to query a bunch of accounts from my system and saving it to Salesforce to show you how we can do that. ID from account, right? I'm gonna just say limit 1, just a simple code. Now it's very easy actually to push this code to instance, right? We want a true IDE should actually be able to push this code to when I save this, right? If you remember Eclipse, when we did a save, we used to do is it used to take this and put it into the Salesforce, right? So how can we do that here? So let's go look at that particular class. So we have this class where I actually, what was that, generate data. Okay, so this is a random class that I pulled from Trailhead. Let's see, does nothing but generate few data for me. So I'm gonna go say generate data.
I think you've got a typo in your script.
Yeah, but let's actually compile it and see, if it has a typo. Now the typo is for my Apex PMD. I've violated a lot of Apex PMD rules by writing this, and that's why it might be showing this. If I have a typo, let me actually compile this, like push it to the server. It'll show me.
It's just the name of the.
Yeah, got it. Okay, yeah, that's cool. No worries. So yeah. Okay, so now let's see. So we don't have this, right? We don't have this method that we have. So what we can do is we can say, yeah, deploy source to arc. Now, when I push this, it's going to only push that particular class. So you can see it's running, it's running generate data, and it's pushing only that particular, class to is deploying to Salesforce. Now it uses metadata API behind the scenes. So now you can see it says, yeah, it was successfully able to push it. If I make some mistake, it would have told me that this is the error in this panel, in this output panel. But yeah, I mean, when I refresh it, I would see this. There you go, the new method that I added, right? It's there here. Similarly, you can create a bunch of Lightning components, Apex classes, whatnot. But one thing to remember is we are using unmanaged packages to pull in. So if you create a new class or a new thing, make sure that you actually add it to this unmanaged package, because that's the container that's being used to generate that package XML for you, right? So if you add a new class today or a new Lightning component or a new component, it's added to your environment, right? But it won't be added to the package automatically. We can fix that certainly with some more automation here. But yeah, at currently it will not add it. So next time when you generate your package XML, that you'll have to, if you prefer to add it manually, make sure to add it here manually. But it's better to keep everything as a package, right? So you add it to the package. That's why you can generate back the package XML again and sync it back from the server, right? So this, okay, so this is the demo, simple demonstration of how you can generate package XML from your Salesforce CLI itself, how you can do it, how you can do the development, right? You can do more. You can pretty much save your things automatically from here. Create classes from here. It provides you ability to do all those things. Like if you look at here, provides you ability to create class, create trigger, create this Visual Force component, Visual Force page, deploy source and retrieve source. So all these things. Now, if you make a change in, let's say if you make some change in the, let's actually go make a change in one of these classes actually. Let me add another method here directly on the server to show you what happens. I can retrieve that. So yeah, get contact. Hopefully I don't do a typo. Yes, there you go. Forgot an Apex. Okay, there we go. Can it compile? Okay, so it got compiled. So you overrode this. Now, one thing that basically I miss about the the Mavensmith other thing, they really showed me if there is a diff. When I try to push or overwrite to my environment this particular code, it used to show me the diff, that there's a diff between server and whatever you're pushing. So currently that feature is not there in the Salesforce extension for VS Code. But what, again, so the whole point of this is you're actually working in your own environment. You're not working in some other environment, so they allow you to actually override it, and they assume that you're tracking that somewhere. You're tracking it in your head, probably, or writing it somewhere, and know that you modified this, you need to pull it. It works on some assumptions. Again, not super clean at this point, but yeah, it gets the job done. So now I can actually pull one of the classes from the server. I can say, yeah, retrieve this source from the server, right? So it's retrieving now. All right, perfect. So what it did, it actually retrieved it. So I can see the new method that I have here, right? So you can write back to the server. It just gives you that IDE experience that we are used to in the old school Mavensmith or other IDE that we have been working with, like Eclipse and things like that, right? So it gives you that capability. So similarly, if you add if you go do some config here, for example, if you go create a bunch of fields, you go add bunch of fields, or modify a page layout or anything, that you have done it. And as a developer, you go to the package and you add it to your unmanaged package. Basically, at that point, once you add it, you run that package XML generation script. It actually generates a package XML based on whatever you have here. And then you run the retrieve command. As I said, you actually don't need to run the retrieve command. I've enhanced the script to, say, yeah, retrieve DX. The script is called retrieve DX instead of generate package XML. So it automatically takes care of, retrieving the source code from the package, creates the package XML for you, output it into the proper directory here, and then takes the whole source code and converts the DX and overwrites whatever is there in your local. So all those things can be automated. And I've done some automation, and I'll share some more gist with you guys here shortly. So that's pretty much the demo of it, but I want to show you some more cool features that are there. So as I said, this script is actually also can be used for changesets and to move between one sandbox to other sandbox. The problem with the changesets today is, if you move a chainset to a prod or other environments, it takes you forever, right? You might have noticed it takes more than 15 to 20 minutes sometimes half an hour, because it has to go to the cloud first and compile there, and then come back and deploy it right to your instance. So it takes some time. You can actually use this script that I have to actually, as I said, instead of in that script where I put the name of the unmanaged package, you can actually substitute with the name of the chainset, and you can pull all the components there, and then use that whatever you have to deploy to the other instances. So the next demo that I'm going to do is basically the deployment demo. So we saw the developer workflow demo. Now the Git also, so this one also provides you, the VS Code also provides you ability to actually connect to a Git. I'm not showing that as a part of the demo, but you can connect to the Git and store the whole metadata, right? You can store the whole metadata in your DX format of your existing code base into the Git, so that you version it basically. So now let's take a look at so versioning that in the Git will actually solve a lot of problems for you. You don't have to worry about what are the things that you actually change, because you'll be committing to the Git repository, and which will automatically take care of versioning for you. Okay, so now the next demo is actually, how do I push it to another instance, right? I have this unmanaged package, right? I have this other unmanaged package and everything created here. Now I want to actually push this whole thing into another new environment, right? Where I want to run a deploy. How do we do it through the IDE? What are the steps, right? So again, the first thing that I'm going to do is authorize another environment here. So if you go to the command palette, you can authorize as many as arcs you like. But the caveat with this currently, whatever the plugin that Salesforce has built, so when you authorize to another environment, that becomes your default username. That means the previous one that you have is no more the default. So when, in case you do anything from your ID, that will be performed against that particular arc. So ideally, what you should do is you should use command line. With the command line, it will actually automate further things for you. With the command line, the alias that you authorized previously. So it's alias. So for example, in this case, dev arg1 is my alias, right? So I can come back to that and shift it as I want, to that particular alias via the command line. So let me actually authorize one more environment. So I'm going to say authorize, and this time I want deploying to another instance called dev arg2. So I'm going to say dev arg2 and say enter. So now it's going to open the what it's going to do is it's going to open another arc, basically, that you guys can't see it because it's on my other monitor. I don't know if you guys can still see it. Maybe you see it. Can somebody confirm, please, for me?
Can see a Salesforce page right now.
Okay. Yeah, that's great. Okay, so let's do this. So let me pick another environment that I want to deploy this to. Maybe this one. I don't know if I have the username for this password properly. Yeah, there you go. I don't have it. Let me try this. There you go. It works, but I need the code. Let me grab the code. Just give me a sec here. Six 98221. Verify. Okay, allow it. There you go. Authorizes it. Authorized, right? Now, unfortunate. Okay, so this is another org, basically. I have no idea what this is. Maybe some org. I just authorized it so that I want to watch the deployment that goes. So now, as I told you, right, what happened here, as you can see, is it actually switched to another org. It actually switched to another instance, dev arg2. Now I've lost that dev arg1, but you can easily work around that currently using the command line. So in the command line, Salesforce has this command called, let me go to my guest. So Salesforce has this command called sfdx force config set, where you can set the default username. Now let's say I want default username again back to my dev arg1. I can just say this equals dev arg1, and this should actually switch me back to dev arg1. There you go. It switched me back. If I go back to my VS Code, I'm in, where is my VS Code here? So yeah, I'm in my dev arg1, right? Let me switch back to the dev arg2 that I authorized it, right? And I'll say dev arg2. There you go. Let's switch back to that. There you go. So I'm switched back to that. So now let's run the deploy command. Try deploying this basically. So to deploy this again, we can click on the package XML. So we can say deploy source to org. Hopefully there's no surprises and this gets deployed. Let's see. So I'm gonna say deploy source to org. I'm gonna click on the package XML and say deploy source to org. Yeah, and let's see. So where's my second org? Where's the org? Let me find the org where it's deploying. I think this is the one. Okay, so if you go to your deployment status, you can actually track that, right? 11 a.m. Did it really succeed? Did it? Oh, there you go. It succeeded. So let's go to the objects. So it's quite fast, right? So I can see the board type, board review objects, right? Let me validate the fields. So I have this field. It got namespace because it's a namespaced arg. That's fine. Anyway, so as you can see, it deployed, it deployed to another arg. I was able to actually do it, right? Pretty quick, right? In changesets, it takes forever, right? You upload it, you'll have to wait, it'll have to compile, then you'll have to accept the chainset, blah blah blah. It takes time, right? Specifically, I can understand that somebody wants to take control when you're deploying something into the production, right, via the chain sets. But if you're deploying to UAT or partial fold, you want it to be instantaneous as far as possible, right? So you can use VS to your code and all those new things that Salesforce has added, to move code from one instance to another instance, right? You can actually further automate this by writing some more shell scripts. If you know shell scripting is by something like this that I wrote. So this one basically, so what I want to do eventually is where you can run one shell script and provide two org aliases, right? And the chain set name. So what that's going to do, and probably this is an exercise, if somebody wants to build it in the community. So this is a great idea. So what we want to do is, so somebody's going to type that shell script command and say, I want to move whatever is the source org name, alias name, and the second org alias name, and the chain set name. So as soon as we provide that, it should automatically retrieve from the first org and deploy to the second org, just by one script. That's the ultimate goal of this. With that, I think we would have automated a lot of things here. But the CLI, what I wanted to actually stress on that is CLI actually provides you that capability, right? That capability, and it has under the hood all these good APIs, right? So that provides you that capability that, it's a lot more flexible, a lot more powerful than, and we can do a lot more automation with just simple shell scripting, and building our own plugins also. So the other thing is building plugins. So all these can be put into plugins as well. I'm not going to show you in this demo, probably some other day, some other thing. So we completed this deployment. Let's look at something interesting that this IDE provides, which I'm sure Eclipse did not provide previously, or did not, at least was intuitive enough to leverage it. So one of the other things that you can do is actually execute an Apex script somewhere, generate those logs, stream those logs into your VS Code, and offline debug it, right? So let's actually look at it. How do we do that? Just a demonstration of how we do this. So we will have some time for Q&A at the end. I think this is probably the last slide, and then I have some references. Let's do this quickly. So what we're gonna do here is I'm gonna create basically a text file. Let me call it as Scratch Apex. Okay, I'm just writing some Apex here. So Scratch Apex. So let me actually execute one of these methods, right? One of these methods. So let's say I want to add some debug system.debug. Let's say I want to add some debugs here, right? Or add a debug. Let's say I want to debug this whole thing that's going here. Okay, so I want to add a few more debug statements. Now you know that I can easily, let's put some more fields here. Name, what are the field facts, probably phone, etc., etc. Last name. Okay, so I added a few more debugs. Now I want to actually see these debugs without, without having to actually go to my Salesforce. So first, let me actually try to deploy this thing, or basically deploy the source. I added a few debugs, so I'm gonna add a few debugs here, and gonna just run this. Got failed. See, now if there are errors, it's gonna fail. So I purposefully Was it purposefully or accident? I don't know, but it's a good thing. It demonstrates that, it did not deploy because there was something wrong here, right? I misspelled something. Let's go back and do this, right? And you can watch all these things, by the way, here it uses metadata API under the hood. So you can watch deployment status here, deployment status. So it got succeeded. The previous one got failed, has more robust error, right? Why it got failed. This is the one that got succeeded. There was just one component that I was deploying, which was this. Okay, so all good. Now now I want to debug this, right? What variable is coming? What is the account ID that's coming, right? So I have a Scratch Apex actually that I thought of writing, which basically is gonna do a few things. That's it. So I'm gonna go here and do some anonymous. Now this is just to demonstrate in the real world. What you will be doing is you'll be actually executing that particular trigger, or opening that Visual Force page, or if it's Lightning components, actually working through that Lightning component, and that's going to generate the logs. Now to generate the logs, simply here at this point, I'm just executing anonymous Apex because I want to actually show you. I want to show you how to execute few things through the one more power of this ID, right? Which is basically, no, somebody is actually pinging me. Okay, so it's a get contact get thing. So I want to execute. So one of the features is actually you can click on here and say view command palette, and you can say, so before I do this, actually, I'm going to do a few things. So one thing you can do here is go and say, turn on Apex debug log for replay debugger, right? So this thing, actually what it does, it allows your IDE or allows your extension to basically start streaming. Okay, so I'm gonna say turn on Apex debug log, right, for the replay debugger. So I'm gonna do this. This is gonna run a bunch of things for me under the hood. Basically, it's running this, right? It's setting some tooling API commands, right? So it did set it. It did set it. Now, okay, so I turned that's the first step, and it's very important that you turn that on. That provides you, that is how it syncs the logs. So it's a prerequisite. Now what I'm gonna do is to generate some logs. I'm gonna just say view, and I'm gonna say command palette, and I'm gonna say, where is it? So execute anonymous with currently selected text. So this is one of the coolest features that it provides. When you execute this, it's running backend. It's actually running this particular class. It generated few log. You can actually see that log file here as well, right? It generates that log file that we usually are used to, in Salesforce UI. What I'm gonna do is I'm gonna say view command palette, and I'm gonna say, let's look at all the SFDX commands. So there should be a command to say, where is it? Where is the command? So get Apex debug logs, right? Once I do this, it's gonna get me all the debug logs that are there in the debug logs. So which log, it tells you which log to pick actually. So I'm gonna pick this one, which is basically the only one log that we generated, right? Just pulling up that log file. There you go. So you have the log here, right? Now, if you know some more scripting, you can actually keep things better. But the real powerful feature of this is Apex debugger, right? The replay debugger. So what I'm gonna do is I'm gonna put a breakpoint. So if you're used to any programming language, you might be knowing that you can actually do this currently in Java or any other programming language where you can step through the code, right? When the code is actually happening. I'm gonna put some breakpoints here. I wanna watch that variable. So what you can do is you can go to the log file, click on it, and say launch Apex replay debugger with this current file. So as soon as I do this, where is it? So it should actually pick up. Okay, let me go to the code and try to run it. So where is my actual code? So let's go to the class. So let's see. So now it asked me to select the environment, right? So I'm gonna say Apex Replay Debugger, right? I'm gonna say Apex Replay Debugger. Now I'm gonna actually step through my code, right? So where is my, so this, it automatically configured it. So now it's stepping through, right? You can go to the debug mode. Where is my file? It's actually good to open the thing about the reflex debugger is works well when you actually open the file. So this is the file, right, where I was debugging it. So where is it? I turned on the replay debugger. Where is it? Let's try once more and see if this works. So this is not intuitive actually. Struggled it multiple times here. But let's see. Okay, it does work. Oh, okay. I was not on the, wait a sec. So let's close this launch.json. Try to, I'm gonna give one more try and then I'm gonna say this. Still executing that piece of the code. Okay. Let me give one more try and then I'm gonna make another video of this, how to work with it. So basically what it does is, with the replay debugger, what you can do is you can actually step through the code and see the variable values actually flowing through, which basically seems to have something here. Okay, forget it. Basically, if you look at one of the demos in the Dreamforce or thing, you will actually find it out that there is a way by which you can actually keep generating. I mean, these files can be used to actually show some of the static and the local variables, and you can actually debug it. It's pretty neat feature. I don't know why it's not working for me here. Maybe because maybe I just executed this anonymous epics. I did not execute this whole code. That's why it's not actually stepping through the code. But yeah, if you run a trigger or anything like that, it actually steps. You can put a breakpoint here and actually steps through that. You pretty much see that. Okay, let's open for some questions here. If anybody has any questions, if I know them, I'll try to answer it for you.
Hey Mohit, so I think there are a couple of questions posted in the chat.
Yep.
Do you want to take a look?
Yeah, sure. Okay, let me actually get. Let's see.
I can read out the question. One of the questions is, I would like to see how version control is being integrated with this, if it's possible to explain.
Yeah, so I'm gonna explain it since since it'll require some, I should have set the Git repo. But basically, if you, so the VS Code actually has baked in functionality of integration with the Git. So you basically create a Git repo, and then you go to that same folder basically and link your Git repo with the folder, your project folder, so you can actually keep the track of the version or push it to the repository.
All right, I hope that answers that. And there is a next question from Kavya who asks, can we also set the trace flags? I think that you already did in the demo.
The trace flag setting from the command line, yes, we can. Yeah, from the command line. Yeah, so there's a command to actually set it. The IDE does it automatically for you. But yeah, if you want to actually take control of it, then you can, you can go through that command. It's documented in the Salesforce CLI guide, and you can run that based on that.
All right. So are you able to access the chat?
Yes, I am.
More
I am.
questions?
Yeah, I am actually. So I'm looking at the questions. So, okay. So the session will be recorded. Why not add it to Package XML directly and skip the package? Tom Gain. So this is a great question. Like, why not? No, I don't know what it means by package XML and skip the package. So you cannot. So the reason why you can add it to directly the package XML, but the thing about the workflow that I was showing you, the package XML generation is done by Salesforce itself. When we actually manually add it to the package XML, there can be errors. We might not put some things there. While when you add it to an unmanaged package and generate the package XML out of it, we are pretty much guaranteed that Salesforce is going to take care of, Salesforce is going to take care of that package XML thing for you. And sometimes we have some new metadata component that we even don't know what should be the package XML equivalent for it, and we have to go through the metadata API guide to figure it out, and etc., right? While handing it off to the server, the Salesforce unmanaged package container and the mechanisms that I was showing you, the metadata API retrieve command, it automatically takes care of that. So less error prone basically. And also the dependency somebody mentions, yeah. But retrieve from the entire org has limit. I think you can pull up to 10,000 metadata. That's correct. I mean, so the moment you think your org is actually reaching that 10,000 metadata, you must not first of all code your org such a way that everything is monolithic like this, right? The idea of DX project is you create small projects and small unmanaged packages, or unlock packages basically. So you have to actually modularize your entire org, so it's good to use modular development practices. Like, for example, you want to put all the core functionalities and core utilities in one of the package, and then if you're building on top of it, you put it into a separate package, etc., right? You break that metadata depend so that you cannot have more number of those many tags. Like, you can manage it pretty easily, both in terms of development and debugging, right? You don't want to pollute it. Yeah, so other thing is version control and continuous integration, right? It's pretty simple. With the same flow, you can use any CI tools like Circle or Jenkins or Travis. It's the same principles apply, right? You authenticate to the org and you run the deploy command by providing the directory and the package XML directory, right? It's going to take care of deploying it to okay, I think the Apex pulls based on the trace flag set at the user level. That's correct, Ravi. What do you prefer, VS Code or other IDEs like Maven Smith with Autom.io? So the Maven Smith, the current development has stopped, right? So that's why we don't actually prefer that. I mean, I don't prefer Maven Sprint anymore. I've switched to this type of using VS Code and the CLI to do the development. Do we have a compare history like Eclipse ID? The compare history, as I said, you know, I don't think VS Code tracks it, but there must be extension on top of VS Code to track it. I don't use any of these because, you know, I use Git. So if you're using version control, you can track that. But is it as precise as editing the package XML? I don't understand this. I mean, precise as editing the package XML. I think so. I mean, it's basically it's precise. You know, if you generate it from the unmanaged package, you're guaranteed that you have proper package XML. You know, in the shell script, I'm not doing manually crafting that package XML. Now there are tools and there are npm modules which actually can handle that for you. You know, where they manually generate it, but I you know, manually generating is always error prone. So how do you compare VS Code extension and IntelliJ plus Illuminated Cloud? I think IntelliJ plus Illuminated Cloud, I mean, IntelliJ is good, and Illuminated, I mean, I'm sure the Illuminated Cloud, whatever, has automated a lot of these, and it's a paid tool, so it will have its own, you know, advantages compared to VS Code. VS Code, the good thing about VS Code is like it's open source, and the extension for Salesforce is also open source. So if you're a developer and, you know, you don't want to pay for it, you want to use it, you know, you want to build yourself, you know, during the process of building, you'll learn a lot of things. So it's good to, you know, use VS Code extensions as well, you know. And Salesforce is actually actively building that extension, right? So in coming releases, we hope that it gets better and better and has a lot more functionalities. I have 7 more minutes, so if anybody has any questions, you know, please bring it up and we can discuss it as a team.
All right. I think it was a wonderful session, and we have been able to take at least a couple of questions. So thank you so much, Mohit. Thank you everybody for attending. And this session is recorded, so it will be uploaded on the YouTube channel very soon. And Mohit, we look forward to many more such interesting sessions. Thank you so much for your time today.
Thank you. Yeah, thank you.
All right. Have a good weekend, everyone. Bye-bye.
Thank you. Thank you.